welcome to another episode of FooBar. Today I'm at Ikea and I'm still on holidays. But don't worry, after this intro I leave you a podcast that you can hear. I recorded this podcast a couple of weeks ago with Jeremy Daly and it's really cool intro to Appsync. So go and check it out, go and check Jeremy's podcast and I see you next week with a new video in FooBar. Bye bye!
Hi, everyone. I'm Jeremy Daly, and you're listening to Serverless Chats. This week, I'm chatting with the fabulous Marcia Vilshaba. Hi, Marcia. Thanks for joining me.
Hello, Jeremy. Thank you for having me here. And I hope my cat is not meowing because she's already meowing. So
that's fine. My kids love cats. I'm sure the people listening will love them as well. So
she always appears in my videos. So it's part of FooBar.
Yeah, perfect. So you are a full stack developer and an AWS serverless hero. So why don't you tell the listeners a little bit about yourself and what you've been up to lately?
Yes. So I've been doing serverless since 2015. So Lambda was launched in November 2014. So I started quite early on, more or less when API Gateway was announced and was able to connect with Lambda. And since then, I've been just working in different type of projects. My first project was just to migrate something to serverless, and then I've been working on greenfield projects most of the time. And then one of the things I really like is to create content. So I think besides my job, that's what I do the rest of the time. I just create YouTube content and a lot of courses, and I have a small consultancy where I help companies with workshops and trainings and things like that. So I spend all day doing this serverless stuff.
I know that feeling. And you have a blog too, right?
Yes. Well, my blog is not really a blog per se. It's more or less where I gather all the content I create in one place. I used to use Medium, but I quit. So I think blog is more like I can do whatever I want with it. So
yeah.
It's just a place to have my content, but most of the content I create is video. It's the place I feel more comfortable. So YouTube is the place I hang out, and I just put everything there. But well, the blog is good too.
You do an amazing job with all of the videos. So thank you so much for all that stuff. So I wanted to have you on today to talk about AWS Appsync, right?
Cool.
So I've seen you do your talks before. You have a great talk on this subject and you've done videos on it, things like that. So maybe let's start by just, in case people don't know, because I think this is one of those, it's not obscure if you are in this world, but if you're just kind of getting into it, I think Appsync is maybe an obscure sort of thing and why that's different than API Gateway.
Exactly.
So maybe you could tell us what is Appsync exactly?
Well, in few words, Appsync is a GraphQL service. So it's managed GraphQL service by AWS. It's a platform where you can AWS will take care of all the heavy lifting for the GraphQL. And you just basically need to put your schema and create your resolvers but basically the schema and the resolvers are the two proprietary things that you need in order to have a GraphQL application. The rest is very generic between every GraphQL implementation. So AWS create this platform and then you just do the smallest amount of work you can and get a working GraphQL server. And that's really good. For example, creating mobile applications is really fast to create fast backends for mobile applications or to interconnect multiple microservices or do all kind of things. So it's a very interesting service.
So it's basically like a managed Apollo server.
Well, yeah, Apollo has their own platform as well. So they have their own Appsync. So yeah, this kind of concept is... when I talk in my talk about the ways, because GraphQL is a specification, it's not something that somebody somebody wrote it down and then different people implement it in different ways. So there is like 3 ways of doing GraphQL, as I said. Either you write your whole GraphQL specification yourself. You are a hardcore developer, you want to have your GraphQL done in COBOL, and then you do it yourself. I don't know why. Then the most common way is that you use some library like Apollo. That's the most popular library that you just and put it in a server and maintain that server. And this kind of serverless way of doing GraphQL is using a platform where all this heavy lifting of maintaining the infrastructure and doing all these small connections that needs in order to hook up your library to your server are already done by the platform, and you just focus on your business logic. That is the main mantra of serverless.
Awesome. So let's actually talk about GraphQL specifically, because again, it's another one of those things where I think a lot of people are very used to REST APIs. That has been the way to do things for quite some time. I think it was Facebook that came out with GraphQL, and
yes, GraphQL was released by Facebook, but now it's owned by everybody. So
yeah. But so now, so maybe just quickly explain what is GraphQL exactly.
So first of all, GraphQL and REST are not like enemies, so you have not to choose one or the other. And I think that's an important starter for the discussion, because people are like, well, I will ditch all my REST endpoints to use GraphQL. No, we are not talking one or the other. They are two different things. So GraphQL is a specification that when you implement, it has, usually it sits between all your microservices and your clients, and it does like an entry point for your application. So you can, instead of having multiple different endpoints that point to different microservices independently, you can have one entry door. And that's really convenient. For example, if you're doing, a mobile app, and you have multiple different microservices with different people working on them, then you can combine all these requests and responses into something that is like a contract between the client and the server as a big entity. So that helps a lot the client developers, because that's one of the big problems when client developers are starting to work in a project. They need to get really understanding the whole backend architecture, and sometimes there is really not a lot of need for them to understand that. So GraphQL will provide a contract where all the possible operations are specified. It's a strongly typed language, so all the operations have request and response with really clear defined types that they have strongly typed, so you know exactly what you can put in, what you can get out. And then when you do these operations, that you get a type back or many types back, and then you can in your request you can ask for exactly the same the right fields that you want from this type, because that's another problem with REST in general for mobile developers, that they need to overfetch a lot of information a lot of the time and do the filtering in the client. And when you are working in mobile apps, then if you are fetching a lot of information, that's a lot of bandwidth, and you might need to do a lot of requests to the backend. And GraphQL will unify everything in one response request. So it's in a way quite efficient for mobile development.
Yeah, and you mentioned overfetching, and I think that's one of those things where you run into that with REST APIs, where again you can't say. Well, I mean, and you can design REST APIs to act as like a GraphQL server in a sense where you limit what comes back, but you also have that problem of underfetching, right?
Yes.
I mean, so you bring back your list of products, but then you want to get the product details, and you have to make additional calls.
So the idea is that you can fetch many resources, many types in one request. So you don't need to fetch one and then fetch another one and fetch another one. So that's kind of one of the benefits of GraphQL when you use it. So in general, it's a good combination to have both REST and GraphQL. So for example, if you have, in one of the projects I work, we had a backend with GraphQL. By that time, Appsync didn't exist, but we were just working with plain Apollo. And it was really good because we have 16 different types of clients, so from which we maintain 4. The rest were maintained by different type of people. Some of them were consultants that were paid to do this specific application for a smart TV, for example, and it was never maintained again. So GraphQL really performed because you don't need to really synchronize a lot of documentation back and forth, because with this contract, everything is specified there. And then there is no versioning in GraphQL. Everything is done in one contract. So you evolve your API with time, and GraphQL has kind of ways to do that. So it's if you do it right, it's very easy to be backwards compatible and support all versions with no problem. And that's one of my favorite features, because when you're working with REST, having version 1.2.3.1.
Does anybody actually version an endpoint though with REST API? It's always so I'm like, well, we're on version 1, but it's really like version 9 at this point, because you keep changing things.
I have seen version 49, so yes, I have seen.
Okay,
version.
so some people do.
Yes.
But what I like about GraphQL is that fact where it's like you can add a new field, or you can add a bunch of new fields. You can add nested fields and things like that that you just keep adding to your schema, and really the weight or the need for maintaining backwards compatibility, it's all done via the clients.
Exactly.
And the clients can just enhance themselves by using these new endpoints, but you don't have to get rid of them because they're not being sent down in every request.
Well,
for new clients.
you have a chance to get rid of them. For example, if you are changing something in your backend and you're not just returning that field. So they have these two concepts, that is hidden files and deprecated files. So fields, sorry. So you can play with those concepts and start removing attributes from your types if you need so, or you can tell or this type is not valid anymore. You still can return it, but we will not, it's a way to communicate with your clients, because at the end of the day, sometimes you cannot return always everything back, because the backend change and you need
eventually. Yeah, well, and that's what I actually love, that metadata deprecated stuff that you can put into GraphQL. That's another really cool feature. So let's go and talk about resolvers for a second, right? Because I think this is one of those concepts too, where people that are new to GraphQL, what exactly is a resolver?
So I said
GraphQL?
that at the beginning that Appsync is a kind of already packaged GraphQL platform that where you need to put your schema, that is the contract between the client and the server, and then the resolvers. So the resolvers are the unique way that your GraphQL middleware kind of component will connect to the different microservices. So that's very proprietary from every application. It's basically a set of instructions. So imagine that one of your microservices, we can call it data source. That's the word that Appsync use, because they might not be microservices per se. They can be things like a SQL table, like a relational database. So imagine that one of these data sources is a relational database, and we have a type that is, order, and we have a table that is order. So we want to link our GraphQL type to this table. So the resolver will need to understand SQL. So we'll need to open a connection to that data source and do select all from the orders table. And if you have some condition or if you have some fields that you need, so we'll need to write this SQL query, and then it will need to get the results back from the table, parse it in a way that it becomes JSON. That is what GraphQL puts out in the response. So it's doing all this translation between the client and the server. So it's a very, very critical part from GraphQL.
Yeah, and I hear a lot of people when they say GraphQL server, they sort of think that's sort of the end all, but it's really an intermediary where you have a client request that goes to the GraphQL that sort of does this assembly of all, or calls all these resolvers, puts everything together for you. But it's really not the server. That's not where your data is coming from.
No, the GraphQL it's not a database. It doesn't have any information itself. It's just handling requests and pushing it to the other side. So it's kind of just translating in the middle. If you were speaking English and I will be speaking Spanish, and we'll have somebody in the middle that is translating.
Well, you speak beautiful English, so I wouldn't worry about it. All right, so let's get into Appsync now, because this is where I think we can start putting all this stuff together. So you've got GraphQL, you've got the structured language that you can use, you've got this concept of resolvers. So Appsync is serverless, or right? In the sense that we don't have to worry. It's a managed service. Yeah. So we don't have to worry about the backend servers. So how does Appsync work? What does that do? What's that flow via Appsync?
So when you start with Appsync, you need to set up your schema. So you need to define all the types of your kind of GraphQL application, what is GraphQL returning, and all the operations that the users connecting to this Appsync or GraphQL server can do. So you will decide, okay, they can create orders, they can update orders, they can see all my orders, and these are my types, my orders, my products. You find all that in the schema. The next step is to set up what are your data sources, where the data for populating this schema comes from. So you need to say, okay, I have an SQL table, I have a Lambda, I have an Elasticsearch, and you connect the types with the different data sources or the operations with the different data sources. And when you do that connection is when you build the resolvers, that kind of linking between the schema and the data sources is when you need to write the resolvers. So when you use Appsync, a lot of things come out from the box if you're using AWS services. So for example, well, the schema is you need to write that you cannot escape. But the data sources, it has kind of really native connection with Dynamo, Lambda, Elasticsearch, RDS, and I think the next one is HTTP in general, so you can call whatever you want. So those are the 5 data sources that you can use pretty easily. And your resolvers need to be written in a specific language. So it's using this velocity language scripting or velocity template language, VTL. I'm very bad with acronyms, sorry. And that's kind of one of the trade-offs when you are using someone else's platform, that you cannot decide which language you want to write your resolvers in. So
I don't want to interrupt you, but
sure, you can interrupt as many times as you want.
Okay. So before we move on though to getting into the VTL, so we mentioned these data sources, and you said Lambda, you said
Yes.
Dynamo, HTTP, Aurora, and Elasticsearch. So those are 5 very different types of
Yes.
data sources. And so when you're talking about building a resolver, when it's DynamoDB or it's Aurora or it's Elasticsearch, Appsync will actually be the resolver for you, or the resolver will be built in.
You have templates. So for example, if you're using Dynamo, you can just go click on Dynamo and then it will show you a template. Okay, you want to fetch 1, you want to fetch 2 items from a list of items, or do you want to insert something on Dynamo? And you just click on the template and it will kind of create a resolver for you really easy. The same with Lambda. If you want to invoke a Lambda, it kind of comes out all from templating. So it's very, very easy to get started to writing those resolvers.
But the idea would be is that essentially that VTL, the template that you create that can do that translation between DynamoDB and your schema,
yes.
That kind of acts as your server, the other end of the GraphQL.
Yeah, that's your business logic, kind of.
Exactly. And you're right, it does that business logic. And then if you do want to do very specific business logic, though, then you can do that. You can do that with a Lambda function, yes. Or call another service, another HTTP or something like that.
VTL is very powerful. So that's something, sometimes it happens, people underestimate what kind of things you can do. You can do really a lot of things only by playing with VTL over Dynamo. Is super crazy, the things you can do. And then if you want to do some complicated operations, you can always call a Lambda and do whatever from Lambda. And then also Appsync has this feature called pipelines, where you can connect, for example, a Lambda, different data sources together. So imagine that you're fetching a profile metadata, and you have to do like one of the fields in that metadata in Dynamo. We have the profile information metadata, and one of the fields is linked to a photo in S3. So then you can hook it with the pipeline and fetch that image from S3 and create this kind of signed URL that you can return back and show in your web app. And you can do that pretty easily with Appsync and this pipeline concept that they have, that you can connect as many data sources as you need together to return something to the client.
Yeah, that's a pretty cool feature.
Yeah.
So what else about Appsync, or what are some of these other features? Because it goes beyond just being a managed GraphQL server.
Out of the box, one of my favorite things is security and authentication, because that's always something. If you have a mobile app, then you always have some kind of barrier between like all your data, your personal data, and the world. So that comes out of the box with Appsync. So you can get started super fast with Cognito. It's super simple to set up. And then you have username, password, or Facebook signing, or Google signing, or whatever you like from Cognito. And then there is also other more specific ways to authenticate. But I think the most common way is to use Cognito. It's super simple to get started. You can use an existing user pool or create a new one. And then you can even filter inside the fields that you don't want to show this information to everybody else but you. For example, if we go back to the profile example, that you can fetch this profile information, and if it's Jeremy's profile, I will be seeing some filter out data, and Jeremy will be able to see all the data, like your email address or your phone number. So you can create that with very simple BTL connecting Cognito and Dynamo, for example, without writing a line of Lambda's code, for example.
Yeah, and I think people need to understand the importance of that, right? Because I've worked with GraphQL before, and then you've got security where it's sort of like, well, GraphQL doesn't do security. It's not, that's not part of the specification there. Your resolvers have to handle that. Exactly. And if you have to write that code into every resolver and then manage it across all these different things, it just gets really complicated. Yes. So the fact that AWS has Cognito and you can do the federated logins across all those different social networks and things like that, or plug it into Auth0, or even write your own custom one. I mean,
exactly. You can do whatever you want, and there is quite a lot of, they keep on adding different authentications ways, but I think Cognito, if you want to get started, is the easiest way.
Very fast.
And it's really integrated with all the mobile kind of platform development that they have AWS built. So all the libraries and everything works really well with Cognito. So
all right, so why don't we talk about maybe some of the use cases, because that's the other thing about Appsync where I think it confuses people is it sits, or it originally was sitting under the mobile. It was classified as a mobile service, right? Because it did some. I think actually that you could do WebSockets originally. There was some real-time stuff that you could do there with it. So what are some of those use cases that you can use it for? Not just with mobile, but with just a web app or any other service you want to use.
So I think the easiest use case is building mobile apps. So as you mentioned, Appsync supports real-time communication out of the box. So that's one of the benefits. If you have an app, you don't really need to sync it, ask the server every 10 minutes, have you updated the information? So that happens in the background with Appsync. So that's a feature a lot of mobile developers are looking. Because sure, you can have WebSockets with API Gateway, but that's something the client will need to create all the support for that. But with Appsync, it just comes out of the box when using Appsync. So for me, the strongest use is to build mobile apps. But in general, whenever you have multiple microservices and you need to unify them in some kind of way, I think also it kind of works very well. If you have client applications, not only mobile, but desktops and things like that, that works very well. And also it's a very good way for managing when you have these client applications that you cannot control, like in our case that we have all these like 8 different apps that were managed by externals, and in a way it's kind of easy to have this auto documentation in place, because let's be honest, we are very bad at writing documentation, developers, and when you're in a very agile world, then things tend to go faster than the documentation goes, and having something that kind of enforces the documentation just by its nature, it makes life so much easier.
I was told very early on in my career that the code is the documentation.
Exactly, and GraphQL is a proof of that.
I don't agree with that, but anyways, that was what I was taught. So some of the other things it does too is like offline sync, right? So if you make changes on a client, it'll store that information, and then when you do get connectivity, that'll sync up, and then you obviously have conflict resolution that it needs to deal with, and Appsync does that as well.
Yes, it does the simple conflict resolution. So if you have very weird things that you might need to create some kind of resolvers there, but for the basic things, it just does it on the background. So it's important to understand when you use Appsync in the client, you will need to have a library in your client, so to handle all these things. And that's kind of, it's not something that happens magically. You will need to use a library to connect to Appsync in your client, either web or mobile app. So it will do all the connection and the magic between the server. So
All right. So what if I don't know if we can do this via audio, but let's say someone's driving in their car and they just want to get a sense of wiring up a data source in Appsync. Right now, obviously, they go and watch one of your videos. You've got plenty of them on this. They probably can't do that when they are driving or maybe mowing
it's
their
not
lawn.
a good idea. Don't do that.
No, not a good idea. So but just quickly, just walk us through what that process might be.
So first you create a schema, and then you need to link the schema with the data source. So imagine that our data source is a Lambda, and we want to invoke that Lambda. So basically what we will do is just write one line of BTL that says invoke this Lambda, and you pass the parameters that are coming in the request. It's super simple. And then you need to write the Lambda that will do all the magic. And then you will return from the Lambda some result. And then you need to write another piece of BTL that will be the response resolver that will grab that response that Lambda did, that we imagine that is a JSON that can be returned like it is to the client, that will just grab whatever is in the response of Lambda and push it out. So that's super simple kind of example. If you want to connect to Dynamo, what you do is you write a Dynamo query like the ones are very similar, like the ones you write using the AWS SDK, just with a little different format. So you will put like get item, you will create this kind of params object where you put, I don't know, the key, the table, and whatsoever in the BTL. And then you need to write again another velocity template for the response, that if you are getting just one item, it's just basically whatever Dynamo returns, you just push it out because Appsync knows that format and can do all the transformation for you.
So bottom line is learn VTL.
Yes.
Awesome. All right. So what about performance of this? Because I've heard stories, people are like, oh yeah, super slow when I'm trying to connect multiple data sources, things like that. What is your advice around, or what are your thoughts on performance?
I think like everything in life, you need to understand a little bit the things that you're connecting together when you try to go to production. If you're playing in your home, you might not care that much about performance. But in general, my experience and the people that I've been talking to experience of Appsync is very positive. But when people start telling you about performance, it's because they have done some kind of mistakes in their architecture. So one common mistake is people don't want to learn BTL. So they do lambdas for everything. And lambdas are quite fast, but it's an added latency in your system. So if you are calling Dynamo and the BTL can do all that, why to call a lambda that might be cold, that you might need to launch and deploy and call the AWS SDK and return and fetch? So that's one thing. Then another thing is that people like to scan in a Dynamo table.
People love scanning Dynamo DB tables. I don't know why.
That's the most inefficient thing you can do in a Dynamo table. They're not meant for doing that. And Appsync is so easy to get started that it's very easy for people to start scanning Dynamo tables. And that's where performance gets totally kind of screwed. Because if you don't know, scanning Dynamo tables goes in kind of one row at a time. And Dynamo is a big data source, so you have lots of items there in general, so it's not meant for do that. If you want to find data, use other ways. You can index that data or then put it in Elasticsearch, or I don't know, use something else. But don't scan Dynamo tables. Then another thing that people like to do is to sometimes connect to HTTP. I know it's a data source, but you need to be aware that if you're connecting to an HTTP data source, then you're adding more latency there because that's going outside to the internet. So everything you do has some cost in general. It's not like when you're inside your own network and everything is ready to fire. So I think those kind of things is good just to have it in mind and see how you can improve that. Can you build a cache in front of your HTTP somehow, or can you do something to speed that up? If it's something you need to do, it's something you need to do, but sometimes it's better to avoid that and put everything in Dynamo.
Yeah, and I've seen HTTP calls. Just, I mean, it probably takes 90 milliseconds just to
exactly.
set up the HTTP call, and then you have the latency that's added there.
Exactly, and then you have like you need to do some weird querying that people don't know, so they call a lambda. That lambda then calls an HTTP, and then it returns back. And I have seen all those things, and then sure, performance is not the best.
So bad architecture or bad queries. I mean, that's the thing. So I think that's one of those. That's that learning curve when you start working with all these services. Anyways, understanding how they stitch together and what's the most efficient way to do it. So, all right. So that's great. So let's actually talk about implementing this now in a serverless project, right? So how would we go about doing that? You mentioned sort of client libraries. What do we have to do in order to start using this?
So the first thing is to create the backend. So you can either go to the AWS console and click around and have your GraphQL backend using Appsync, or if you want to have a real production application, you need to use some kind of infrastructure as code. That's my recommendation, that you can build the whole Appsync service out of configuration files that you can replicate in different environments if you need. So Appsync supports CloudFormation. So if you're using CloudFormation, you can use that. I've been using it with Serverless Framework because they have a really nice plugin where you can basically build all your Appsync infrastructure, which has writing some files and creating some really simple specification there. So you create your schema file, you create your resolvers file, and then you have this plugin in your infrastructure page that, like in your Serverless YAML, if you're not familiar with Serverless Framework, where you just type all these links. Okay, this is my data source, this is my security, these are my resolvers in this case, these are my resolvers in that case, and it's very simple. And then that means that you can have the same GraphQL backend for dev and staging and then production. So you can create 3 different stages for that, or I don't know, whatever you need in your in your production. So that's the first step, to create a good production backend. The second step is to create your clients. So that's you will need to use AWS Amplify. That's the easiest way, in my opinion. AWS Amplify is a client library that AWS has created. It's open source, and it's kind of, I think it's called like a cloud for enabling cloud native applications or something like that. It's just a fancy naming.
I think it's CDK, Cloud Development Kit. Is that
no?
Is that different?
I don't know. They have all these names, but yeah, the thing is that this library is really cool because it integrates really seamlessly with a lot of the cloud services. So you can also use it for connecting to API Gateway if you're using API Gateway. So it's not only for Appsync. So it has features like it creates your authentication, so you can connect to Cognito. You can get your session there, and then you can use it for GraphQL, for Appsync. So when you set up your GraphQL backend, you will get like an URL back and then some other information. With that information, you put in your configuration file of Amplify, and it's kind of working. It's super simple to stitch together. And the same way you can configure Cognito, you have to know your Cognito user pool, Cognito identity pool, and some other thingies. You put it in your configuration file, and then you can start calling the different APIs from that library, like I think sign in, auth, login, or something like that. And then it's like GraphQL get, or like it's very, very straightforward to use.
Right. So if you want to run, like once you have that all set up and you're logged in, and is it No, it's not Amplify, but Cognito, for example, same with Auth0, has the login interface for you. Like you don't even have to write that in your client application. Like that's just done.
Yeah, you can do that as well. But if you want to have an application that looks like the whole application belongs together, you can also do that with this Amplify library as well.
So once you're all logged in and you're ready to go, now you want to run a query. How do we do that?
So in general, you write the query I usually put it in a separate file in my client application because it's easier for me to manage those. So I have a file where I have all my queries, and I will write, I don't know, give me all the videos, for example, or all the orders with these attributes I want to see from the order. And then I go to where the logic is executing, and I just use the amplify library, the GraphQL part, and I just do, okay, get me this, and you will get a JSON by just passing the query.
No, we didn't talk about mutations. That's another.
No, we didn't talk about queries and mutations. That's part of GraphQL, actually.
Yes.
We are like three sections back.
but just so obviously queries are when you actually call it, and that's what the query language is it's a query. But then you can also send updates and make changes. So you're signed in, you can write your queries, you can run your queries, mutations, and so forth. That sign in, that, like you mentioned, the Cognito user poll, the library automatically sends that authentication token up to Appsync.
Yes.
And then Appsync uses that, and then all your ACLs, your controls, and your that's all done in your velocity templates.
Exactly. And for example, when you pass, like you're logging as Jeremy and you want to see your profile, so Amplify will hook in your Cognito ID, and then Appsync will see, oh, your Cognito ID is the same as the one that I'm allowed to show you the email, birthday, and whatever. And that's all done in the resolvers. So it will return the whole profile to you so you can see it. But if I want to fetch your profile, it will say, no, Marcia is not the owner of this record. So she will be only to see the name and the photo, for example, and that's it.
So you mentioned, okay, so you're putting your filter, the ability to filter what certain people can see. We're doing that in VTL.
Yes.
Maybe we're doing some of that. Would we do it? Would we offload any of that into Lambda if we were using a Lambda resolver, or you still would want to do it at the VTL level?
Well, then is the question on who owns the data, and that's something, at least with Appsync, I'm still trying to figure out how to really architect my application, my GraphQL applications, because I've been using GraphQL with microservices, and usually I do the filtering in the microservice because the microservice knows the data, knows who can see it, and I don't want to leak that information out. But with Appsync, at least the applications I have building, they are mostly contained into Dynamo tables and Lambdas. So I think when I'm coding this, that Appsync is the owner of this data. And then I do the filtering in the resolvers. So I think it's always a question of who owns the data and who is able, like, where is the level that you want to leak the information out. I don't know if it's clear, but
no, I think I totally agree with you, because I mean that's always the problem you have with a lot of the security things where I mean obviously when you're using API Gateway and you're using Cognito or OAuth, and you can send in you can do the custom authorization. And then you get back a policy document, and then you need to use that policy document to that can restrict certain higher levels of things, like whether you have access to a particular endpoint. But if you want to take that information and then actually build logic within your application to say, don't show this if a user isn't in this group or whatever, you can go even further and do that at that level. But now you've got some of your security happening at the at this level, and then another there, and I guess that maybe even begs the question, where do you put your business logic? I mean, how much do you want to be putting business logic into VTL, or is that something you still would want to keep out of Appsync?
And I think this is a really interesting question in general for serverless, because when we are working with servers, we know that the server is the gatekeeper of data, and like this is the quite clear boundaries. But now we have this serverless world where there are all these kind of functions and different managed services that have access to the data. So how to regulate that I think is a bigger question than Appsync. Sure. I think it's something I wonder myself every time I design a serverless application. Like, who owns this? Who is the who has the power to access this data, and who can see it all and who can't?
Right, and that might need to be a conversation for
Yes.
another day.
Philosophical question.
Just a couple more technical questions that I have. So custom domains with API Gateway, you can stick a nice little custom domain on it. You can't do that with Appsync.
No, not out of the box as you can do with API Gateway. So you need to go through the CloudFront distribution and do like Route 53 and hook up there the thingy. Because in general, Appsync is thought in a way that nobody really will see your URL, because it's an application to, like, your client is connecting to your server, so you really don't care. Mm-hmm. So I think that's the thought when this they have not put that feature in. Maybe they put it in the future. I have never needed, but you can do it if you go through the distribution in CloudFormation and do all these kind of thingies. That then you can link the URL that Appsync gives you to the one that you get on.
So you just set it up. You just set it up as a custom origin or something like that.
Yeah, something like that. I have not done it, but I have read the documentation is there. If you need to do it, you just Google Appsync custom domain, and it's the first thing that will appear. AWS information on how to do it.
And it's probably not necessary, like you said, with a normal, if it's your own app. I mean, maybe if you're exposing it to be like a public GraphQL API, you'd want to do that.
But Facebook or GitHub or something like that, maybe you care. But in general, most of the use cases, at least I've been working with, and in general, people have been working it. It's like you have this mobile app, and you want to hook it to Appsync, and
most people aren't Facebook or GitHub, so they probably don't have to worry about
it. And maybe if you're Facebook or GitHub, I don't know. Will you put it in Appsync? I don't know.
Probably not. Not if you're Microsoft or Google, probably. So last question, because this was something that I know has been asked before. So API Gateway handles stages, which is kind of a cool little feature. You can't do stages directly in Appsync, though, right? You just have to publish like a different version of it, or a different
not a version
endpoint.
You need to publish a different application that will have its own lifecycle. That's what I was saying when I was talking about the implementation, to use the infrastructure as code. So then you can create multiple kind of stages, fake stages, in a way that there are different versions, like different published applications with the same configuration, just with maybe the name change and some data sources change and things like that for each of the stages. So you have to fake it in a way.
Awesome. All right. Well, listen, this was fabulous. Thank you so much, Marcia, for being here. And honestly, thank you for everything. Your FooBar videos and stuff like that are excellent. Great tools. If anybody's trying to learn serverless, definitely go check that out. So besides that, what else? How else can listeners get a hold of you? I mean, you're pretty much out there, but
I'm very active in Twitter. So that's the place I write. So usually I'm there putting some tweets, and also in Instagram. I use Instagram for conferences. I go there quite often, so I do a lot of live stories and share a lot of information as it comes out from the conference. So those are the two social networks I use besides YouTube. So you should find me there.
And that's MAVI, the number 888 UY for Twitter, and FooBar _codes for Instagram. And then you have your blog is marcia.dev, marcia.dev. And then if you go to YouTube, you just search for FooBar Serverless and you can't miss you.
Yes, exactly. And pick the worst keyword in the word FooBar. But
well, nobody ever uses that. What are you talking about? Well, anyways, all right. This has been awesome. I will get all that information in the show notes. Thank you so much.
Thank you for having me.
And that's this week's Serverless Chat. I want to give a huge thank you to Marcia Villalba for being my guest this week. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/3. You can also connect with me on Twitter at Jeremy_Daly. And if you're interested in serverless and want to discover all the great new articles, use cases, and latest innovations from the serverless community, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me this week, and I look forward to chatting with all of you again next time.